Welcome you all, the eminent speakers. We just had very knowledge sharing insights from the distinguished speakers on our panel. So while starting with the panel discussion, I open with a general question. See that technology and sustainability, they are having a key role in managing energy uses in real time start building infrastructure. Now it is being powered by IoT as well as AI, which is demonstrated the energy saving of 15%. So the question is talking about solutions, what green thermal technologies are best for public buildings and how AI can improve their efficiency or the occupant comfort level. Let us have your views, Mr. Viral, first.
As I said in the presentation as well, public buildings, I think the first part would be to reduce the load, and then comes the picture of AI, net zero, and then is to follow. But I think the first part would be to reduce the consumption at the design level itself. And definitely, as Subramanian sir also said, that with integration of AI and the BMS part, because right now the major problem in public buildings is the operation and maintenance. Design wise, a lot of buildings are efficient, but then once it is handed over to the O&M or the maintenance department, there is where the problem is. A lot of buildings, what we have seen is during commissioning, for example, a small thing in AHU rooms, the dampers are closed, the fresh air is not coming at all to save energy. So things like that are happening a lot in public buildings. Hence, I feel with integration of AI, when it is automated, when where human involvement would be less, the efficiency and those things can be streamlined in a much better way.
Thank you very much for presenting your views. Coming next to Mr. Subramaniam, you were also mentioning about the technology integration, building automation system, BMS and all. So what are your views about the AI improving the efficiency?
See, AI is a powerful tool, actually. And the kind of data which comes from the BMS, building automation, when you are connected to various equipment, air side, chilled water side, pump side, and space, especially to maintain thermal comfort, indoor air quality, and all that. I think it plays a very, very critical role because, let's say, for example, you walk into a building, let's say a public building or a government or a private building. If you see a dashboard in front in the reception area, the BOC, the AIAQI air quality index it gives you a number. The temperature, average temperature, it gives you a number. Humidity, it gives you a number. CO2, it gives you a number. That itself will give the comfort feeling to the either the occupant or the visitor and everyone. I think we are little far away from that. It is started to happen in buildings, but I think it has to happen more and more. More and more buildings should have these kind of things. And public buildings definitely can have all this. It's not impossible. It should be available. But AI is especially very important because with the amount of information coming, with the amount of technology available within India for us, it can crunch data. It can go beyond the normal control cycle, control logic, what we generally do from a BMS. Okay, that is there, that is doing a job. On top of that, you can try to do some kind of a higher level optimization. It can bring about a lot of advantages for the building operation, energy efficiency levels, and more importantly, and also the thermal comfort. I feel that it is a tool where you can give it to the hands of the occupants. Everybody can access, give a feedback. I think those things are more important. You should take a feedback from everyone. Are they feeling comfortable or not? And that should give a response to changing of set point, increasing or decreasing your. So I think that will improve the performance, efficiency level of the occupant, their comfort levels and things like that. So it's a very good tool in going forward. It will play a great role in that, and it should. The more and more buildings come with that, the price points are going to be less, much more affordable, so that every BMS can go with an AI. I think the days are not far away, but still we are in the transition stage now because we have still not stabilized the normal BMS.
Definitely. Uh, feedback is very much important to proceed and go ahead. Thank you very much for your deeper insights. Coming to you, Mr. Vikram.
So I was very happy to listen to all the speakers today,
Yes.
Viral, Vivek, Jose, and Subbu, who spoke a lot about technologies and active work which we are doing. And so, in answer to your question, existing public buildings and new ones, they all need to be, first of all, checked whether they are green or not. There are good measurements for what is a green building now, and there are so many factors. But let's focus first on energy efficiency. So it's very easy to repurpose and retrofit an existing building with higher efficiency systems. And another thing which we have to do is to stop leakages from a building or infiltration. Older buildings and even current buildings, if they have not been checked for that, we will be wasting a lot of energy cooling that building. And you have designed it green, as Viral said, but not so in operation. And the last thing is that we can improve the quality of insulation. We can retrofit insulation to reduce heat ingress. So all these things can really upgrade a building into a modern building. And the last one I wish to say that we can improve performance by air motion. So there are equipment called high volume, low speed fans, which have been introduced in public spaces. In Mumbai Andheri station, you will see those large fans. In Mumbai Terminal 1, which is closed now, these large fans are operating. We ourselves in Mumbai have introduced these fans in Mulund Church, where the noisy, low-level fans were working. And with those high volume, low speed fans, the improvement of comfort was very, very advantageous. And in an air conditioned building, you can raise the set point by having better air motion. So this way, green buildings which aren't green can be made green in operation. Thank you.
Thank you very much for the fabulous ideas you have just provided, Mr. Vikram. Coming to you, Mr. Vivek, what are your views about AI introduction?
I think both AI and smart controls both are important because we can go for the best of the best equipments, but when it comes to a real world situation, the best equipment is working on their worst efficiencies. So the smart controls are also needed and the AI both are important so that system could work not only on the diagnostic approach, but it can also work on a prognostic approach. So when your equipments are running and they are able to communicate with each other properly. So first and foremost is the overall efficiencies. It is not only the one equipment which is consuming energy, but it is the whole building which is consuming energy. And HVAC is the major juggler which consume major energy across all the things what we have in a building. We can have the AI driven controls analyze the real time data from sensors placed throughout the building, which includes your temperatures, occupancy, weather conditions, which allows the system to make informed adjustments. And the pre-detective maintenance enabled by AI can identify potential issues in HVAC system before they occur, which enables proactive maintenance and reduced downtime. And that is why AI and smart controls both are important.
Definitely, Mr. Vivek. Thank you for sharing those points. Coming to you, Mr. Jose, what are your views about the AI introduction?
I will say that it depends actually local climate conditions, building use, finance, policies that are available in the country. When we speak about green building, sustainability, I think we have spoken about the high performance insulations, this passive design, heat recovery, smart glazing, but then is where AI enhance the efficiency and comfort. These kind of systems dynamically adjust the building operation based on real-time conditions. What happens, for example, in educational buildings, for example. Educational buildings, the use of the building or the space of the building will depend on the classes you have in one space, and then one space will be without people or with people. So this kind of consumption can be traceable, and also you can make some efficiencies if you automate that with AI. Our colleagues, they were speaking about BMS technologies in BMS, automatization. So this kind of technologies help to find efficiencies in all these solutions, depending on the use, depending on the typology of the building, having a predictive model, predictive maintenance, helping to avoid equipment failures, ensuring that sustaining thermal performance are over time working without waste. So that is the revolution. That is coming. I mean, that is what we expect to be more accurate through the time and increase the add values that this solution.
Thank you, Mr. Jose, for sharing those points. Coming to Mr. Vikram, coming to Mr. Subramaniam. Mr. Subbu, you were talking about the energy saving solutions, thermodynamics, and you also said system is important than the equipment. And while you were talking about the district cooling systems, so how can district cooling system benefit utility campuses like airports, universities, schools, cities?
See, let's take airport as a first example. Airport is not going to be a standalone building. Going forward, even in Bangalore, they're talking about developing some of the areas near the airport, where the hotels are coming up. For example, you take Delhi, the existing AeroCity. Now, there are somewhere around 20 hotels possibly. So if you talk about 1,500 tons for each hotel, it's around 30,000 tons. Plus the airport itself will have around 10,000 tons. So you have 40,000 tons of refrigeration in that small area of 2 square meters or square kilometers or something. Now, each building has got its own chiller of 300, 400 ton air-cooled, water-cooled chillers and all that. Imagine if either the GVK or Adani or someone had installed a district cooling system for, let's say, to start with 10,000 tons and expandable, scalable to 10,000, multiples of 10,000 tons. Your power demand, your burden on the electrical infrastructure on the Delhi Electrical Authority is going to be much less. Your cost, your kilowatt per ton consumption is going to be much less also. And they can start selling chill water to all the hotels coming up, all the offices coming up. And for the core, another important thing is if a hotel is coming up or a hospital is coming up or office space, their core business expertise is something else. They can concentrate on that. Now, instead of focusing on doing air conditioning, all those kind of, so they can do the interior part, but at least the chilled water is available to you the way the power is available to you today and water is available to you. Now, the way, electricity power and water is made available to every building, I think our mindset, the paradigm shift, the mindset has to change. The chilled water is going to be made available at the doorstep of every commercial building, either be it private or public. I think that kind of mindset, if it goes into it, and it will also give you advanced planning, it will give you a lot of things, everywhere. This is there. Its only thing is there is some kind of a coordination required. You need a master developer. You need a master architect. Architects also have to put their minds in. We have to possibly first train the architects on district cooling, maybe the development, because they are the first people to enter. If they don't pump in that logic and, that will go on. I think it has started spiraling, but it has to come as a revolution. It is a quick revolution we need. Otherwise, your ICAP and BE, the kind of electricity demand that you are requiring for cooling, it is going to go sky high with the kind of urbanization we are talking about. Air conditioning becoming a necessity instead of luxury. Every residential building needs air conditioning. And abroad, if you take all condominiums, they are all having district cooling system. Now, why not we have that here? I think, lot more can be done. But we are in a very sleep mode. We have not woken up yet.
That's a fabulous idea, Mr.
We have to face the real fact. I mean, I'm sure Mr. Jose will agree. I think we have to go on a fast track. We have to completely increase our speed and get into action mode.
Correct. Thank you very much for sharing those fabulous ideas. Yes, architects must wake up now.
The architects have to become better engineers, as Vikram said, and engineers have to become better architects.
Correct. That's a mutual role both have to follow.
In course of engineering, you can have couple of sessions on architecture. And architects also can have 1 4-credit course on engineering. Building engineering, something like building engineering.
Yeah, your idea is noted. Thank you very much once again.